Hi, good morning. This is Andrew Kay and Kevin Pruce, and this is the presentation for our heat exchanger design. For the problem statement, each group must provide preliminary design specifications to assist in cooling the MSU High Performance Computing Center. MATLAB is used to create a simulation to represent the heat exchanger. One potential approach for reducing cooling costs of the HPC consists of using drinking water that is sent out to various buildings on campus. Approximately 10 million gallons per day of water flows out of the reservoir. The goal of this is to minimize the pressure drop and maximize the efficiency. This design is modeled as a shell and tube heat exchanger and the effectiveness number transfer unit method. In order to obtain the optimal cost, it's not simply finding the cheapest option. There are other long-term costs such as cleaning fees and maintenance issues. In this code, potable water is considered drinking water for the first mass flow rate, while the second mass flow rate is considered a city or well water for the liquid heat dispersion as coolant.
The code was designed to optimize constraints as variables change. This takes the average temperature of potable water as 57 degrees Fahrenheit and water coolant as 95 degrees Fahrenheit. Code is based off thermodynamic properties which are evaluated at the average temperatures. This code uses one pass for the heat exchanger tubes. Effectiveness varies with respect to mass flow rates, heat capacities, and heat capacity ratios. The goal is to choose an inside diameter, tube length, tube outside diameter, and baffle spacing that will provide optimal variables. I chose to use a shell inside diameter of 3 meters with a tube length of 6 meters. I then chose a baffle spacing of 6 inches with 6,846 tubes. This creates an effectiveness of 0.32. The outlet temperatures were 59 degrees Fahrenheit and 96 degrees Fahrenheit. This also creates a pressure drop of 1,964 and 3,710.
In order to reach a more optimal result, there are a few things that can be done. First, you can run more optimization tests of the many variables. Secondly, you could spend more time experimenting with alternate solutions. And thirdly, you could do more research on heat exchanger tubes.
In conclusion, Bunke is a leader in development and production of heat exchangers, which is a possible supplier. And along with that, there are several environmental issues that involve the heat exchanger tubes. And also, these designs meet the required specifications